Hi guys, I hope you're good since the last video. We are doing tutorials, but this is YouTube. Keep in mind that videos are edited, and while it might look clean sometimes, even if I try to keep some authenticity, there are some errors happening. And those errors made me efficient at learning fast. Therefore, it depends on you and what you're doing with those videos. If you open a terminal and start playing with those concepts, you can learn Rust for what you need pretty quickly, especially if you come from Python and any other higher level coding language like me. Making those videos, it is one step further for me to tap into the last step of learning, which is transmitting. I find it fun while using very explicative and fun variable names or creating little scenarios. What are my learning steps for anything? First step, watch a 6-hour to 12-hour video. Second step, come up with creative but simple scenarios, just brainstorming in how I could use those concepts. Third step, code and play with it, make lots of errors, telling to myself, what if I do that? This should happen? No. Okay, why this is not happening? How to fix it? ChatGPT, explain me this concept. This is what I want to do. So you see the type of mindset, the type of mental process I'm using here. The fourth step, transmitting the learning, which is the step being performed in this playlist. And the fifth step, hope that people comment with other ways of doing it better than the ones I have proposed in this Rust playlist, and have people using the comment section to help each other. Hope this helps you. Have a break, have a rest. In this video, we are going to focus on Rust box. It will be amazing. Have a seat, bring some food, open your terminal for the second part to follow along. But before that, we are going to pass through a few slides to explain a bit. There will be a little break as well in this video. Okay, let's get started. Box. What is a box? With the T, a little type inside. So box is holding different types. One type is a smart pointer in Rust that allocates type on the heap instead of the stack. A box is primarily used when you want heap allocation for data that is otherwise stack allocated. Why do we use box? Heap allocation for large data, for example. The stack has a limited size, as you've seen in the previous video, whereas the heap can grow dynamically. So you use box to store large data on the heap and keep only a pointer to it on the stack, which is the box itself. Recursive data types. So you've seen the previous video, we used recursive function. So for recursive types, example, also linked list and trees, that what I'm not using, but also exist with the nodes and those recursive sides, right or left, and it keeps going node after node. Using box allows you to define the size of the type at compile time, as Rust doesn't know how deep the recursion goes. Another reason why we use box, indirection. You can use box to create indirection and avoid copying large data. When you will only need a reference, So here I'm using an example very quick. Is the syntax, box value, box, double colon, new, 10, print value inside box, box value is going to be printed. In the example, 10 is stored on the heap. 10 normally is an I32 or an I8 or an I64 or a U64 or, it's an integer. So it should be on the stack, but here it will be on the heap thanks to the box. And the box value is a pointer to it. So the box is a pointer. Allocate 10s on a heap and return the box smart pointer to point to it. Let's see some different use cases of box. Recursive data structure, that's the one we talked about before. So we have an enum, it has a node inside, box list, I32, and here it's nil. And here we're just creating a list of nodes. So we're making this tree. After making this tree, this creates recursion. Recursive types like a linked list or trees often use box that contain the recursive type itself. Dynamic memory allocation. So use box if you want manual control of whether an object is heap allocated. Trait object. Haven't seen yet, but we might introduce the trait in future videos or in different examples that we're going to use, but not now. So box din trait is often used to store trait object when the exact type is not known at compile time. Even if you haven't seen it yet, at least this is mentioned here once, you know it exists, and later on we will be using it in our code. Ownership and deferencing. A box with type T is the owner of the data it points to. When the box goes out of scope, the heap data is automatically deallocated. To access the data, use dereferencing. So you've seen that the magic start to the reference to have access to the value, box value. You can access to the value like that. Example of stack versus heap with box. So here we use a struct. And I'm going to put the example here so it's all in one page. Let me just fast forward this. And here we have one variable, P1, with an x and y, stored on the stack. But here we use the P2, it's a box, which is going to be putting here the struct with the field defined. So this one is stored on the heap. So when we print here the box, we get access to those. But just to know that you can also put an entire structure which should be on the stack. But you can put it on the heap like that, but using box new. P1 is allocated on the stack. P2 is a box that points to a point allocated on the heap. Advantages of using box type: heap allocation for large data that doesn't fit well in the stack, enables recursive data structures, provides indirection, and is useful for trait objects that we might see in the future. Downcasting. What is downcasting? Refers to converting a trait object to a concrete type. So we just going back from that reference to the original threat to the original object. It's typically used when you have a box in threat and want to get back to the specific type it originally stored. In the example, we have a variable boxed, a box dynamic any, so any type. The box here takes this integer, and after here we're going to be checking the some int, so we're going to use the function which is available in Rust by default, is downcast reference. And here we just infer, we just check if it is an I32. This is an I32, it matches. And here the sum is going to check if it is validated, it's going to be printing the int in this formatting. So downcasting checks the type at runtime. It's very important to know, because usually everything is checked at compile time. That's why the compiler can return you some errors. Here it permits, so using box permits to actually check types at runtime, and allows you to convert from a threat object, the int threat, to a concrete type, here I32, string or any other. It could be any type here. This is different from dereferencing, as it involves type checking and conversion rather than simply following a pointer. Yes, so you've seen ampersand. Ampersand is just going back to the value, reading the value, get it back. While here, when you use a downcast reference like that, there will be more operations happening. There's some type checking, there's some conversion happening under the hood. So there is more stuff happening. It's good to use box, but you know that for the performance, there will be more stuff happening. So this time, it won't be the best performing way. Let's go to the terminal and see that we can use box in different ways. We're going to go step by step. There will be different examples, and I will be commenting along and fixing the errors on the compiler. Okay, let's start. We're going to create a new file. Nano, I'm going to call it boxes.rs. So let's start commenting a bit. Now that we have seen several concepts, you won't be afraid. You won't be afraid. See me putting some decorators. We are going to allow that code and activate debug for enums. Let's create our public enum. So we're going to work with the Mangakisa zone. Which has different fields, and here the field attendance is going to be a U64. The field temperature, which is going to be a float 64. on the field comment, which is going to be a string. Let's build up those decorators. It's just to get a clean terminal when we're compiling, but we might get some errors which are gonna make it messy anyway. Example 1. So this example, I'm gonna start slow. I'm gonna print the enum, which as you can see has different types in it. We're gonna call it a box for us. It looks like a box of different types. So print manga zone debug mode. So this function is going to take a vector, of type, let me just copy here manga zone. So that will be the type of the vector elements. And we're just gonna return the vector. So vector is, let's use the printing. It's a custom type, so we need the debug mode, or we need to implement display. We're not implementing display, that's why we use the deriv debug decorator. We're using the allow dead code decorator because we might, for some examples, not use the enum. So just to be ready. Here, not that. This is a trick to allow vectors to have different types. So that's a trick. If you wanna, because you know vectors, you just need to define one type. But if you wanna have several different types, you can use this kind of unboxing. That's how I call it. And use enum, put your different fields with your different types in, and you put it in a vector as type, use it as type, which is normally accepting only one type, to hold different types using enum. Okay, I'm just going to copy this, put it in the comments. Close those comments. So now we are ready to go in the main.rs. Okay. And now we are going here to import. We're gonna try to import everything. So the function and also the enum. You know, when you create an enum, if you want to use it in the main function, you need to import it. So let's see if you remember how to do that. Let's go down. Everything is prepared here. So the module, which is boxes. And here we're gonna use crate. That's the trick. I have to put crate first. I have to call the enum using the boxes module that you have created. So the enum is Mangakisa zone. Now we can use it from here. So here also there will be the print of those different examples. So we have the module with the functions, and here we will be building up some variables and pass those variables into the functions. So here we are at example 1. Print an enum. Let vect call it let vect box from enum. Okay. It's a kind of box, it's a vector, and we use an enum for that. We're going to use here the macro vect to make that. After here, we're going to build up our different elements which are of type Mangakisa zone. So we had attendance. I'm just going to put a number here. It has to be a string. No, it has to be an integer. Use 64. Mangakisa zone temperature. It has to be a float. So let's say 31.9. Let's say we're in the summer. It's hot. I'm going to put another type in the middle comment. So in the enum comment was coming last. So here intentionally put it between those two. So we're going to build up a sentence which is ampersand string, and here we're going to make it to string. So string literal. Now it's converted to a string. I'm going to put those in a different order, just for you to know that the order doesn't matter, to make it short. That's why I did it. After, it's up to you with your terminal while you're following along to play with it, to try different combinations. Try to omit one field and see what's going to happen. Okay, we got our fields, our values. We are ready to close the comments. Vector, we have instantiated. Let's just show here attendance, temperature, and comment. String, float 64, unsigned integer 64. We call the function. I'm just going to copy it. We're going to pass in the vector, which is of type Mangakisa zone. And we're expecting to get this kind of print. So we need the last line here. Println. I might not even need to use println. So just let me do this. We're going to put here boxes. We're going to add the columns, call the function that we have copied, and we're going to pass in the vect box from enum which has only fields. MangaKeys has own fields, so it should be fine. Okay. Just gonna put it like that so I can see. I'm gonna pass this here. Okay, this message is gonna be enclosed. Let's see this. Cargo run. And here we go. So this is validated because we got it printed. So that's all good. Get the comment on the temperature. So this was a little introduction to start slow. Now we're going to be going into the subject of the video, the boxes. Just let me put this. Okay, now we can start our second example. So that's not a real box. Even if it can hold different types. When we talk about box, it is about memory. So what we did before doesn't change anything. Here we talk about memory allocation and referencing those, let's say, for example, stack variables. You're going to be able to move those into the heap to get bigger variables, or to just play with it because you have some operations to do, heavy operations to do on those variables. And we don't want a Stack Overflow because of the recursion, for example. So create real box and the downcast. We're going to be just jumping into this box concept and downcasting. Let's create our public function. We're going to call it box simple downcasting. So that's our introduction example to the boxes before the hard one, but the most interesting one just after. So here I'm just going to be passing a vector, simple box. Let's get some space. It's returning, it's gonna be a vector, this vector simple box of type box. So din any, that's what you have seen in the explanation part of this video. I will be commenting on that just to explain what is din, what is any. Now that we got a vector, we are going to iterate over that vector. So .iter, we get those elements. I don't know how to do the indentation here. It doesn't really matter. You just do the indentation the way you find it looking the best. Just put everything in the right place, so between the curly braces. So for element in vect simple box.iter. If let, we're gonna check the element using the function available in Rust downcast reference. We're gonna be commenting and explaining why we're using some. There's a reason. And here, we're gonna be downcasting on the reference and checking if it is an I32. If it is an integer I32. If it is validated, so the sum val, now we can use the val to print found I32 and we print the val. So val here is just a placeholder. You can put whatever you want. So I'm gonna start commenting maybe here. Just let me get some space. We're not gonna write a book, but there will be a lot to comment, just to make sure you understand. So we retrieve values by downcasting elements. So each element will be downcasted. And we're doing by detecting the types using the evaluation with sum. Box, din, any returns an option. So we've seen options in the previous videos in this playlist. So an option returns a sum, some value, or none. It's a way in Rust to return none. Okay, so here that's why we're evaluating using sum, because we got that element is a box, so is an option. So returning that option, we do the evaluation, and after we use downcasting ref on that element. What is downcasting ref? So this is gonna be doing those operations of converting those values if needed to. So the box is like a pointer. This is possible because we have any. So any, we will need to import it. So any, which helps to know type at runtime. So that's why we need any. That's why we're using also any. It's to be able to tell to the compiler that those values will be evaluated at runtime, not at compile time. But this means that it adds more checks, as we've seen in the explanation part of this video. So there will be checks at runtime, and this can alter the performance. Because it's not just reading, it will be dereferencing, it will be converting. Also, it can be some specific use cases. So you can't be using it everywhere because there's a lot of operations happening. You're using Rust because it's efficient and performant. And this is not something that you use all the time. So some form of operations. So using the value behind the reference box. So we can do this check on the types. Just gonna copy box din any. So using box din any, to much increase the chance of getting. So if you use that a lot, you can also get another disadvantage is getting runtime errors. Because depending on the way you code, on the types you're using or you coercing, there can be also the increase in chances of having incorrect type assumption. Because if we say that it's going to evaluate the type at runtime, this means it's going to infer the type. It's going to check on the type. It can also create some errors. So you need to know what you do for you and for the compiler as well. So better keep control on what you're coding and doing by using it only when you believe that, for example, me, I'm just thinking I might be using that if I believe that the operation I'm doing is going to create a Stack Overflow, for example. So this time I'm just going to say, okay, I'm going to box that. So that's the sentence I'm using. Box that. I'm going to box that so that I know that I'm going to put it on the heap to not create any Stack Overflow, or for recursive functions, for example. So here we are getting the elements using .iter, and because it's returning an option, we can check the sum side, downcast the reference. If it is an I32, we return found I32. Okay. So what I might do here is just to do it for more fields. So we did it for the, I'm just going to copy and paste and do it for the other ones. So here we're printing F64, and after here we might print the string. Let's paste this, and here it's a string. So that's the three type of values that we want to detect from the box. And here we can put an else statement, and just to print unknown, for example. If it is a boolean, we wouldn't be detecting being able to downcast it. Unknown type. So it's all about types here, checking the type. Okay. So we got any. So any type can be passed in. But we need to import it from the standard library. So use standard library any, and here we get the any from that. So that's the one we're using to be able to do this those operations in the box. just going to copy the function. We can go to the main.rs. Import the module. So let's import also here any, because I'll be using it. Capital A. So we're going to comment out the previous example. So we'll be doing that, just commenting out the previous example and printing a new one with some different variables adapted it to the example. So for example 2, which is downcasting value from box, from a real box this time. Now we're into the subject of the video. So I'm just gonna create the variable straight away. I'm going to call it vect box Castella, which is a cake. Let's use this time, we use the same, but box dinany. So the vector is going to be having elements of type box any. So those elements, they will be on the heap, and the box reference will be on the stack. And here we create our vect using vect from this time instead of the macro. And now we're going to start building our boxes. As you've seen in the explanation section of this video, we use box, double colon, new, and after inside, we're going to put the type, which is a string type, Castella Japan here, dot to_string. Okay, and we use as to convert. So to get this box being of type box din any, we coerce the type. We are telling to the compiler at initialization of this vector, those are the types. Because here the vector is a box din any. So the compiler expects the vector to have the same type, but here we want to pass in different types using box. So here this one is not a string anymore. This one will be, for example, maybe you can use the integer here. Let's use a million integer. And the third one was a float. The float was the temperature, so 32.9. We're still in summer. And we're going to put everything in an array. So we want this field of this array to become a vector. They are all boxes din any. We might comment a bit on that. So we create a vector. And use the brackets with those elements in. This is like an array that we have defined. And we wrap that in a vect from. So we want a vector from this array. So which is making a vector from an array. So let's comment that. So this is clear. We're repeating a bit what we're saying or what we have said in the previous videos. Rust wants all elements to be same type, like in an array. So I'm gonna put tn, which is the way you define an array. Type on the number of elements. So here the number of elements, it's okay, it's going to be inferred. The type we used as vect box d in any. Therefore, we will use as box in any. So I don't know if I need to explain you din any now or check this. So I'll just get rid of the vect. It's just box din any here. It's as box din any. So just the box type. So they're all the same type. They're not vectors, they're boxes. Okay. Because elements have different types. You see we have a string, we have an integer, we have a float. So string, float, f64, i32 or u64. So here I wrote i32 because that's what's the default. So we must explicitly tell Rust that they are all of type box by using as box din any. So that's why we're converting those to not get those errors at compile time. Therefore, same type. So here will be validated for the definition of a vector in the array to transform to a vector. Okay. Maybe last or second last comment. We are coercing each boxed value. So we are manually telling what are the types of those values. Well, I told you in the previous videos that Rust sometimes can infer the type automatically. So this is the inverse of infer. So here we have to manually coerce those types. And we initialize this vector because they all have different type. So we need to tell what is the common type that they're gonna take. And we want to use the box din any. So we could have used box string, for example, and used toString for each field. But here we want to use the box din any. Here using box din any. We will get an error at compile time. Okay, so if we don't do that, because all these different types, the compiler is gonna cry. Okay, so now it's time to close those comments. It's gonna look a little bit more cleaner. Here we go. If there's any errors, we're gonna fix it. I just need to know what's the name of the function again. Let's go back in the file. I forgot the name of the function. This is when you create the crazy names. Oh, it was easy. Box simple downcasting. So we need that function name to be able to use it. So the module boxes, the function box simple downcasting, and inside we're gonna put our vector. Where is it? Here. Vect box Castella. Inside. Here. Okay. This is done. Okay. Let's clear this. Cargo run. Wow. Let's see. Okay. Let's go back in the main.rs. Let's close this comment. Let's clear and run it again to see what are the errors left. So what did we do? Let me check that. Okay, you can see here else if in this block is the condition of if expression, then it must be followed by another block. So here we omitted the evaluation. So we just said else if, but else if what? We need to say, to put something there. We got a warning also because we're not using the import crate. This okay, this understand. Let's go in boxes and see what we can fix here. So you see here, else if, while the first if let is evaluating some val, and the downcasting on the references of I32, we can see that the other ones, they're just printing found F64, found S string, found the string, but there is no evaluation done before. So that's not what we intended to do. So this time we're going to be copying this evaluation and modifying it in each line. So here it should be an F64 that we check. And here we check on a string type. Alright. This is a big mistake, but it's okay. And now we got printed. We have a little warning. So we found those values. That's great. Let's make it a bit more like a clean. Let's take this decorator because we're not using here, we have imported the enum that you have printed in the first example. Here we're just gonna allow an unused imports. Allow that to get something clean. Let's print again. Here we go, and now we got our found string Castella Japan, found I32, and found the floats. Let's go back in our boxes. So we're going to follow the same steps. We're going to comment out our example. So the following example coming, it's one of the most important example that we're going to show. So we're going to stay on it a little bit longer. And we're going to be commenting a little bit more. So I hope that you have the chance to have a terminal and try those examples while I'm doing it. So this example here, with downcasting, unmutating, using reference, using mutable reference. So here we're going to make it a bit spicy. So we're going to use endmute to make it more fun. So that's the type. Box. Din any. And in this example, I will be explaining the din and any used for boxes, as you have seen in the previous example. Before. Okay. Let's create a public function. We're going to call it box downcasting in Yoyogi. So Yoyogi is a park in Tokyo. We're going to pass in a vector. Just going to put it like that. Vector of type $mut. It's a mutable reference vector, which is of type box din any. Okay. And now let's put the logic in between those curly braces and start working on that. So what we are going to do here, we're going to extend this vector by adding some values in it. So we're using the method push. We're going to push boxes, because that's what the vector type are. Box new, we put a -2. So you've seen that when we have initialized the vector, we used conversion. Here we don't need to convert those boxes when we're pushing those, because the function already received the vector of known type $mut vect din any, box din any. So because of that, here Rust will be inferring, will be using his automatic correction I will be able to know that -2 is a I32, 5.01 is an F64, and the string from, now we write that the Yoyogi Park can be accessed from Harajuku and Shibuya. And you will be able to infer that that's a string. Okay, let me just say here string. Here we have F64. So that's what Rust will be able to default type. So those are the default types. So for string, default type is string. For a float, I haven't said that in previous videos, so here you get the chance to get this information. So Rust default type for float is F64. And let's put a capital R. Rust default type for integers. Integer is I32. Okay, so negative, positive number of lane 32. So I can add, maybe it's using I32 for the efficiency, because more efficient. And here the float 64, why not the float some other floats? Because it's more precise. Okay. So we can also put the types that we want. So we can also not use the default type I32 and use, for example, you see me using a lot U64. So you can also use those types, but you will need to write those in order. For example, you can put here has U64, or you can there's another notation, another way to manually write the type of an int or any other variable. I'm going to show you here for the int. We can also write integer with its type. So there's a way to write it with its type. Like that, I'm going to show you here in this example. So we're going to use an example, not an inside the integer, an I. So for -8 box new -2. Let me just change this to I8. So here -2 I8. So the type will be I8. So that's the way you can do it also. Like that. It's a shorter way of doing that. Let's close those comments. Hope that you have learned something from this. And we're going to keep going in this example. It's still a bit light for the moment. We have just pushed 3 values in the box. So we have pushed those vectors by default in the heap. That's fine. But for example, here we're pushing a string which is not on the heap. It's normally on the stack. But here it will be on the heap. Here, whatever is inside vect, this vector will be on the heap. Memory. While box reference. So don't forget that box is the reference. Stays on the stack. And any that you have imported, it will be able to do those conversions. So referencing the types moved to the heap. Native to heap, side memory. So for the types moved to the heap, I'm just going to process here. If normally stack types, like a string for example, or any integer, okay, so those will be moved in the heap. So here we're just building up an example. So it's just an experiment that we're doing. I suggest you to do your own with your own logic. Here, din. So I'm going to explain din for dynamic. Will permit to figure out the types at runtime. Okay. So now you can be explained what is din and what is any. So you can learn about the word polymorphism. I don't know if I'm going to spell it right. I wrote polymorphism. So polymorphism. So polymorphism. That's what we're talking about here. How I'm going to say it, how I'm going to define that. Go back down. Having, maybe I'm going to put 3 here, 3. Having a thread interface, for example, being implemented by several different structs. So let's say you have different structs, but they're all implementing the same thread, the same, same functionality. So struct here is seen as a custom type. So the structs are on the stack. For example. Okay. So we might see threads in future videos or use it as an example. Okay. Okay, let me finish this long comment. Let's keep this example not overcomplicated. So I suggest you to research more on the polymorphism. We're going to be focusing here on box. Box is doing this polymorphism because we have this dynamic interpretation at runtime. Any is going to help to do those conversions and to access those values. So all those evaluations are going to be done, those operations at runtime. We have a function here. We have a vector, mutable, of type vector box dynamic any. We push 3 different variables, boxed variables. It's going to be infer the type at runtime. Okay, we got that. So this is not all. This is the first part. It was just building this logic and providing you some different explanation that we didn't explain before. We've been using it without explaining din and any. Now you know box is a reference of types which has been moved or on the heap or which lives on the heap by default. We use downcasting to get those types and access to those values. So check on those values stored in the vector. So we're going to use match or iflet. Try to keep going with using what we've learned before. So you've seen iflet already. I've used it by downcasting at a particular point from the vector. Okay, at a particular index point, we're going to be downcasting. It's just to show you another way of doing it. You can also check at index 0, is it this type? At index 1, is it that type? At index 2, is it the other type? So you can check it like that. You choose the index and you want to check at this index because in your code logic, you need at this index in the vector to always have a certain type. If you don't get that type, maybe you're going to do something in your coding logic to do something else. So here, if some val, we're going to check the index 0. We want it to be an ampersand string. We downcasting, checking if it is an ampersand string. So reference of a string. So if this evaluation goes well, we're going to print that we have found a string. Okay. And here we print the value. And we're going to do the same for the other ones. We're going to check some more indexes. Vector. So we're going to check now the first one. So this time I'm not going to forget to put those evaluation in the if statements and the else ones. So here on F64, a float, print. We're going to just change here to float 64. Else if let, and we keep going with the last one. I'm gonna do one more. So I'm gonna get rid of those else. I'm just gonna do if statements, and it's gonna check like that. So I can copy it. I did that just to be able to copy for the last one. So here we're gonna check the third index, which is the number 2. 0, 1, 2. 2 is the third. We check if it is a string, downcasting. Is the type a string? If the type is a string, we get the value. Okay. So here we used iflet instead of match. That's one way to evaluate, to check if there is a value at a certain index. So we got our function. We pass in the mutable vector. We push some values. I don't want to overcomplicate. That's why I go over it again, and after we evaluate a different index. If they are strings, F64. So I just check. If I find it, I print it. Okay, so that's the intermediary process that we have introduced to this function. After here, I can maybe print the separator. So let's put a little separator like that. And let's do something using match to make it more dynamic in terms of research of types through this vector instead of checking one index in particular. Let's create an iterator to make it spicy. We're going to create our iterator and use match. That's what we want to use now. So you can see different ways of doing it and how a match would apply to a box. So that's all questions coming to my mind while I was learning. That's why I'm transmitting, because I believe it's important to answer, just to have an introduction to this language and understand it. So we're going to enumerate this iterator to get the index and the elements. We've seen that before. And now we're going to be able to match. So we put everything in an iterator. We match on the element downcasted with the type I32. Yes, I need here to put you see here is okay. So don't forget the parentheses. So I need to remind you here that don't forget that box din any is returning an option. Okay, So you're going to see here an interesting way to do the matching process. So is returning a sum or is returning none. So if it is verified, we get the value, is returning sum. If it is not verified, it's going to return none. So let's use that to chain the possibilities. So we're going to use this at our advantage by chaining those possibilities. Here we're checking if the element downcasted is of type I32. If it is of I32, we get this sum val printed. So val is a placeholder. You can put anything. So you don't need to put val. Doesn't mean anything. It's just because we want to reuse it after. And this value will be the actual value of the downcasted reference. So the value of the element. So it's going to return val or none. Okay? This we're okay with that. If it returns val, what we're going to do? We're going to print a message. So let's print index let's put it like that so you can see everything in one page. Index I32 equal, let's put another placeholder here, and here we're gonna put index and the val, and we use the debugger mode. We don't want to have surprises, so we just print it using the debugger mode. I'm going to copy this and use the none side now to chain it. So that's how I'm going to do. I just go here, copy paste. When it will be indented, you will understand. We match the sum. We match the none. If you get the sum, we get the value. Okay? If we get the none, we're going to be matching another type. So here I just need to change those types. So the none, we're going to go and chain it and go to, that's how you can have control over the things. F64, and now we're going to check. And we're going to go again. I'm just going to get rid of this line. Okay. And here we're going to do the same. There is a sum. We're going to change the sentence that is printed because it's a F64, so we match on that. Okay. I'm going to do the same again for the next level of checking. So here we're just going to put F64. We passed. That's the third level. So I'm in a box. So I can do that. I can be a bit recursive on that. Keep going on this chaining. String in the heap. We push this here. And at this time, we're at the end of the chain. If it is none, we can print a message. Let's say if it was a boolean, for example. So we would be able here to have this printed. Do I need to check all those indentations, all those parentheses and the curly braces? It looks messy for the moment. So we're going to print index. So at a certain index, we found an unknown type of, and here we might put the element that we've been looping through. Index, not the val, there's no val here. Elements. Okay. So give me a few seconds here just to check. Where is this one? The one for the match. I'm missing one curly brace. Okay. Now we got them all. There were one missing. We have the one for the for loop. This one. This is for the function. We have this one here for the function, which is the last one. We have the function. We have a mutable variable that we pass in a box, in a vector, which is holding those boxes. We're gonna push some additional variables in. We're gonna evaluate different indexes if they are the types that we expect to be at those indexes. If we find it, they will be printed found. We do an iteration around the vect, and we're going to use match some none in the none. If the none is printed, we're going to be checking on the next reference type if it exists or not, until we arrive to the end of it. Just going to copy the function here. Let's nano into the main. And let's build up here our... Let me just comment this as the previous example. So this example is the one in which you see more of the learnings that you get about how to work with boxes. The next example is going to be lighter, quicker, but is something very, very powerful. Downcasting, example 3. And mutating using box ampersand mute to make it more fun. So that's the whole example. Print. Let's format this print. We need boxes. And the function that we have copied. Box downcasting yoyogi. And now we're gonna just pass in this mutable vector in. I'm not gonna create a variable, I'm just gonna passing it in straight away and we're gonna build it. So what we need an ampersand mute. Where is my ampersand? Here. So we're gonna create the vector. Vect from. And let's fill this vector with some boxes. We're gonna be coercing the type. So we're going to be converting those to the right type because we want it to be a box din any. Want the vector to have the same type for all fields. But under the hood, those boxes are going to be different types. Okay, I'm good with the indentation. Almost there. Okay, let's start building our first box. So you know now how to do it. Box, double colon new. And here we're gonna write our sentence, which is gonna be, I am in Starbucks Shibuya watching at people crossing on their different styles, entertains me. Okay. We do toString, don't forget. It has to be a string here. Do the little conversion as box din any. Little trick to have the vector passing the compiling time to get those boxes passing in the heap, those string variables. So just tell to yourself this string is the content of a full book. It's huge. You don't want to have a Stack Overflow and you're passing it in the heap because you have to do some, some rag chunking on it. Okay, so now we got that. This is one box. The other ones, they're going to be quicker to write. So here we're just going to use an int. Let's put here the number, the iconic number of Shibuya, 109. We just push this in like that. And here we say we're going to use 109. I'm just going to copy the conversion as box din any, which has to be outside of the box to convert the box. Okay, not inside. It's not going to work. And after we do some more easy boxes like that, copying this one. One more. This one, let's put the year 2007. Manga Kisa year. And here, let's put 24 degrees. So let's say we're in April. We're in April. In Shibuya, we're watching people crossing and we're checking their styles. It's very entertaining. Boxes, mutable vectors. I'm just going to close this comment first. And after we're passing in different boxes. Just going to put here, we pass in ampersand mut avec okay, of type box din any. That's what it is. As the type is known in the function, just to precise what I told you before, the vect exists. So when the vect is passing through the function, it's already been defined, so the compiler knows let it pass, because it knows that it's going to be evaluated at runtime. Okay, so we initialize it, and inside the function, no need to do those conversions when we're doing the push. When we're adding values to it, those values are going to be inferred, so automatically coerced by Rust as dynamic any type. So when pushing those inside the vector, no need to use the conversion. Just write it here the way we wrote it. We're using any, but yes. Are we good? Just check. Yes, those pushes that we're doing here in the box as box din any, you don't need to do that. Okay, you don't need to do that inside the function, because it's already defined that the variable passing to this function is of that type. So no need as box any type. Okay, is already known, and it's a mutable reference. Okay, I need to close those comments, but I'm gonna add that from here, Rust will, just gonna say it like that, from inside the function, Rust will infer those types. Or we can say it's gonna automatically coerce. So we do manual coercing, we're telling what's the type, but here it's gonna do it inside the function. So just when you initialize, you need to do this conversion, because at compile time, compiler is going to check are all vectors having one single type. If not, if it sees that it has several types in, it's going to fail the compiling. You get some errors. So let's close this. If we get any errors, we're going to try to fix it. There will be some silly errors, and there will be maybe some other more technical. Let's see what's going to happen. We have our conversion done. Just make sure that everything is fine. It's a bit repetitive, but this is the most important example. And you need to understand what's going on. So here we coerce the type manually. That's what we're doing when we use those as box din any here. And there, when I say there, it's inside the function, Rust will infer automatically. Let's close this. This is a well-commented code. Nice. You've seen some blood. Not afraid. Let's see what's going on. Let's see if we can fix it. Okay, there's some typos. There's some missing here. Downcast ref. Okay. So do you see what's the suggestion from the compiler here? So we can see that the compiler is suggesting us that we made an error. We forgot the double colon. And here we get the suggestion from the compiler. That's what I like with the compiler. Sometimes you can really rely on it. And here I forgot the semicolon to close my print statement. And here, help a local variable with a similar name exists. Notice that capitalization, so here I have capitalized val. So that's the error where when val, when printing is in a lowercase, I use an uppercase for the V. We can see that. Also here I say downcast underscore ref instead of downcast underscore ref. So all this need to be addressed and fixed. So there are some consequences to that. All those prints in blue. Unexpected argument of type dnany plus static. But I believe this is going to be fixed if I fix all the different mistakes that we've done. The more typing mistakes, because I comment a lot, and I don't want to forget to tell you this and that. And also I told you from the first video that semicolons, for sure I'm going to forget some. You don't get those in Python. I use JavaScript sometimes, but not that often. So it's not automatic. So I might need to just put those everywhere. Here also, double colon, one error fixed. Here, semicolon, semicolon, okay. So the second error is fixed. And we have the downcast. Here, downcast. And we fix those. And we should be fine. I hope so. Let's see what's gonna print. Just go down to check. Okay. Here we good. We got the curly braces right. Let's clear this. Cargo run. Okay. Ah yes, I forgot to fix this one. The val. So I told you the val here is could find value val in the scope. We see there is a capitalization, help, local variable with similar name exists. Notice the capitalization val with a capital V. After here, so yeah, there will be some other errors coming because of that, but that's not the problem here. It's just because the capitalization of the V. And here we get unexpected argument type box dnany static. So that's the consequences of making one single error. So that's why when you're trying to fix those errors, don't start down the print of the terminal. Just go back up there and try to fix the first issues. So I'm stopping here a bit on the terminal error in order to give a strategy. So I suggest you to start with the first error from the top to the bottom. Normally it will disappear. It will be clear. So let's go back in the main. In the main we're good, I think. Let me just check. The main. Okay, box from here. I need to put the array. Yes. So it's a vector. So we put everything in an array. Vector from an array. Let me put here, it's just before. Okay. And now we can bring this like that. Okay, that's the indentation. All right. Now we're good in this side. So there were also an error here. So this was showing in the terminal. We go again. Now you see there is less errors, and now we just have this one to fix, which is the val error, but all the other prints, the blue ones, they have disappeared since I have defined properly the vector. Let's go back in the boxes file, get rid of this last error. It's nice. You've seen some error handling. You've seen how the print of the error went shrinking. And now we're going to make it completely disappear by finding this capital V. Where is it? Here. This is some val. So it even has a color. Should have seen it. So val, and here val, because it's returning val in a... It's just a placeholder, but don't make any typing mistake. Otherwise it's not going to work. Even if it is just a placeholder. You can put any value. I'm just going to change some of those vals here in the match, just to show you that you can put any value. You don't need to use val everywhere. You can put any value. So I'm just going to use, just let me first print. See, we got the print. Index 0, we got a string, and after we got the value. Okay, we got the print telling us what we have, index 1, index 2. So the evaluation has been done properly, but as you can see here, this is the match which has been printed, but the other one hasn't been, the one in which here I'm checking on the index hasn't been printed here. So index 0 should be an I32. Here it should be F64 on the string. So why it is not printing? So you see, I don't get any compiling error, but I might have made errors in the code anyway, in the logic. So index 0 here it says is a string. Index 1, it's a I32. Let's go to main. And let's make sure that the first index is an I32. Okay, I'm gonna add it here. I change the number, I just put number 1. This is an I32. Cargo run, still not printing. You see, we just get the print coming from the match. Here in the match, it's confirmed, it's an I32. So I might have done a mistake in the code. We're gonna go and try to find it. Let's go back down. So where is the error? The error is here in the evaluation. I'm evaluating an ampersand string at the first index, while it should be an I32. Okay, and now we got the print found at index 0 number 1, which is a nice 32. Okay, so you've seen those prints, you've seen how it works. Now I can close this. I'm not going to change the vals to show you that it's just a placeholder. I might do it in the other example, maybe. But this is the last example now that we're going to tackle. This example is going to be lighter, quicker. It's not going to last long. It is very powerful. It's using an enum as the type of the box. So we've been using vector. In the vector, we've been putting boxes. Those boxes hold different types. We needed to convert those. So there's a lot of stuff to do. While here, we're just going to use an enum. Enum can hold different types already. So you're going to understand. Let's put it down here. This one will be less heavy than previous one. Examples, which, especially the previous one, was the big one to really understand. But now that you can use enum as type, so instead of doing all this manipulation using a vector, putting inside the vector different boxes, having different types, having to convert those, you see there's a lot of manipulations to do. You can just use an enum. This enum has all different types, and you're going to use that enum and move it in the heap using those boxes. Pub. Let's create a public function. We're going to call it custom enum box check. I'm going to make some check on that. I'm going to use match. I'll make sure that the placeholders, they look like placeholders. Okay, so custom box is the parameter passing into this function. It's going to be of type that you already know now, box dynamic any of any type. If let or I put now the placeholder anything, I put our custom enum equal custom box, and here we're going to do downcasting. Downcasting on the reference of type. Don't forget to put the double colon, and here we're going to tell, let's put it here so you can see everything in one page. And here the type will be the type of the enum that we have defined earlier, manga kisa zone. Okay. We use the parenthesis just after manga kisa zone to instantiate it. And after here, we're going to do a match. And let's do the same. So the box is returning sum or none. That's what we do a if let sum or custom enum. Inside this sum, we have this custom box. Now we have this match, and we're going to match on our custom enum. And we're going to do different cases. Manga kisa zone, attendance, placeholder. You see, I put any word here just to make sure you understand it's just a placeholder. And here I'll just let print. So here placeholder is holding the type, the value which is in the box. Let's format this print. Print attendance of Shibuya manga kisa is We put the formatting. And we can call the placeholder to fill that space. So that's one match. We're going to try to match all the different fields that exist in the Mangakisa zone. Just going to copy this, paste it, here we're going to be matching on temperatures. And we're going to print, use the same process here to print a statement using our placeholder. I'm going to change the name of the placeholder. Just going to build this print first. So temperature of Shibuya Mangakisa is, and we put here the formatting, little comma, placeholder, I can put missing. Let me call it something else, just to make sure you get that this can be anything. Can be anything. Nothing more explanatory than this one. Okay, so we had the attendance, we had temperature in Mangakisa zone enum, and the last one, which is the comment. Which prints a little comment. After in the other side, in the main.rs, we are going just to pass in one field to check what's going to be returned. Just to show you that you can use enums for that. Comment about Mangakisa is, and here same, I'm going to change the placeholder and say secret comment, for example. Okay, so you could have used also underscore to match any other element and return something. We have a function. Our function takes a custom box of type box din any. Okay. We use a if let sum on the option returned, and we evaluate that the custom box downcasting reference is of type Mangakisa zone, which is our enum type. It's a custom type. It's here. We have created it. Okay. Attendance, temperature, comment, different field, different types. What is nice with enum is that you can give a name to those types. Match. Now we use match on our sum side. We check attendance, we print it, we check temperature, we print it if it is, and if the type is a Mangakisa comment, we print it. So now we have nice custom types on the heap, and we can play with those. Let me now go in the main.rs. So at this time of the video, normally there are around 4% people left. So you are the warriors. And I hope that you're gonna be excelling at Rust. Okay, let's put here our example 4. 3, no, it's example 4. Okay, 4. And we just say what it is. It's using an enum as type, as box type. Okay, let's make it short. And after, how are we gonna build a box? Can you guess? While I'm writing, are you done with yours? So let Shibuya Mangakisa level 7. It's of type box dinany. It's equal to a box that we're gonna create. Sorry. Okay. Has box din any. So we're good with the conversion of this box. So here maybe I don't need to convert it, but I put it. I wanna end this and have it work. You have to try. You try without, and you tell me in the comment section if it works without hasbox dinany for conversion. Should work. Mangakisa zone, comment. And after here we have a normal day reading books while watching Naruto. I'm gonna put without sound. After we have to convert it to a string, So I suggest you to follow along and use my example the way I'm doing it. So do the conversion as box din any, because the function is taking that type. It's not taking the type Mangakisa. So you don't get any issues of having a box of type Mangakisa, but that's what we have defined. So you need to play with it. That's why I don't give you the full answer. The enum will live in the heap, especially the string type which is on it. And the string type will be moved there. That's because we're using the box. If you need to have less stuff in the stack, or thing that is going to grow and overflow, then at this time you can use box. Just to tell you, don't overuse it. Just use it if you believe that it's gonna overflow. I'm gonna box that. Use my sentence. Do I need to box that? Is it gonna overflow? Do I need to have different types together to do some computation? Do I need to use those super recursive functions, which I don't want to leave on the stack? So boxes, just go back in to take the name of the function that I'm going to call to print it. So here we put a mangakisa, it's a string, so we should have the matching on the string. Okay. And I'll put the variable in that we have created here. Let's call cargo. Let's clear this and see if there's any error. Okay, there's a missing comma. Here, match. Put the comma. I need the comma outside. At least the one inside is not mandatory. And here I need to change this for boxes. Little typo. Here, where is it? This one. I need the comma. And here I need to change the typo. And it's gonna be good for us. So boxes. Here we go. Let's clear this and print it all in one page. Cargo run. Okay. Comment at Shibuya Mangakisa is. And we got here the string coming back to us. Normal day, reading book, watching Naruto without sound. Alright, so you arrived to the end of this video. This was a very interesting experience. We have seen how Box can help to allocate native stack types to the heap for more freedom of use, or to prevent stack overflows, or for recursive functions. We have set a kind of a reasoning sentence for us to know when to use REST boxes. I'm going to box this, that is my sentence, as it could create some problem, or I'm going to box this because it has some stack types and we don't know how big it is going to evolve through the code, or I'm going to box this because of this recursive function. I'm worried that it creates some issues. I want to have more freedom of use. So we have seen downcasting also. So using those references, we have seen any, which is doing the conversion for us, the dynamic, which is moving those stack variables in the heap, and the box reference, which is staying on the stack, having those references, those heap references. So we're going to stop here. Hope that you liked this video. Thanks for the support again. Please like and subscribe, and see you next time for another Have a Break, Have a Rest session.